get it back on the, yeah, proper. No, hold on.
This is the blue screen of death. Got it plugged in. Right, you can wrong the other one.
Welcome. You press something, so you push, when you push the button over there, it went away. Starts it. Oh, we're taking off. There we go.
That's out there.
I think it is too.
That's not me.
Oh.
That's you. Or somebody else.
It's not either of these computers.
Over there.
It's not that one either.
Oh, okay.
Do you mind unplugging it and plug it back in?
Okay.
Get that. So there's an old standby.
Yeah, that didn't even register with it there.
Okay. All right, I'm gonna try the HDMI one time.
We can go ahead and use the one I emailed to you. I mean, it's really not that big a deal.
Okay.
The only change I made to it was just talking about the books that just came out, so I can do that without the,
You say it's at John's or?
I didn't know, I only sent it, well, I sent it to you and Don and maybe John, I'm not sure.
Okay. Let me check.
Try Don's for it. Why it was work on, just a direct connection.
Right.
Work on that.
You have the auxiliary video turned on the flash.
Video,
Yeah,
like, well, I'm not trying to do a Zoom thing, it's just a direct.
trying to get video from there to there. Right?
Um,
So do you have your HDMI port turned on?
as far as I know, it's worked, yeah, it's always worked before.
Yeah, do you mind sending it to
I can't.
John? You can't?
Yeah.
Oh, because
Get on
you're,
it.
yeah, dang.
Maybe I can send it through my phone. I can send it through my phone, it'll. I can just forward the real one
Okay.
and see if that works.
Meantime.
I haven't.
Yeah.
So you can't display.
Yeah. Please stand by. Actually, it went to you. So you went to John, yeah. It went to, yeah, Don and Jerry, not John, we sent it to John.
Okay. Yeah, because then I could just, because I'm on his emails,
Is it
I could just
Astro
pull it up.
or Astro Treasury or?
This is. This is Tulsa Astrobiz.
Okay.
What are you trying to do?
Well, we're trying to get his PowerPoint up, but something happened to the connection for the HDMI to project his computer. So now we're trying this computer again. Can you go and grab the librarian again?
He's in the program.
Oh, he's like in the middle of, okay. Yeah, I got it. Sweet. Okay, well, there's that.
Man, so they used to use it there, start.
We just need to go back to now.
Well, that's just it. We can't get it projected up on here.
Some 6 months. Yeah, I have a feeling this was a projection problem.
Yeah,
Computer problem. But there was something. It just went by.
Yay, Skip to the rescue.
Just for grand.
Okay, can you navigate from here?
Well, yeah, but I mean, why don't we see if it doesn't work?
Away slowly.
We're good on that end, Skip.
Yeah, don't
He's
change
just,
anything.
yeah, he's just,
That makes no sense. Okay.
okay. Wonderful. Okay, and I will let Brad take over.
Okay. Okay, so I'm sure you have all heard about Comet 3I Atlas, which is the one that's coming from another solar system. You might at first want to know, how do we know that it has come from another solar system? Does it have a big sign on it that says that the aliens are here or something like that? No, we know that it's coming from another solar system because it's in what's called a hyperbolic orbit. So it doesn't ever return to the solar neighborhood. It's going to leave the solar system and go from there. Sorry, what? Oh, and there are instances where a comet or other body has been knocked into a hyperbolic orbit by being close to Jupiter or whatever. But this one is in a very hyperbolic orbit. The eccentricity is 6, which is much higher than 1, which is a parabola, and obviously much higher than, say, Earth, which is 0.06 or something like that. So it's a very hyperbolic orbit. That being said, this is only the third one that we've identified as being almost certainly from another solar system. There are a lot of things going on around the news and other outlets about this, and I really haven't been paying a whole lot of attention to those, despite the opening joke. What I'm more concerned about, as usual, is observing the thing, seeing what it looks like, and trying to just see it. It hasn't come in to our solar system at the best angle for us to see it. It's sort of been behind the sun or far away most of the time. It's actually going to be closest to Earth the 17th, I believe, of December. But by that time, it will have gone far enough away from the sun that it's already beginning to dim and won't re-brighten as it approaches us. So it's just going to keep getting dimmer and dimmer. And so at one point, it wasn't expected to be seen hardly at all, especially by amateurs, but it has undergone some brightening. Another clue that it's a new comet, at least, is that it did undergo some brightening as it went by the sun. When comets go by the sun, they usually have one of 3 behaviors. Either they really don't do a whole lot because they're old. Those are usually periodic comets that have gone through the solar system many times and burned off all their gases. Or, I should say, boil off all their gases. Or they will brighten slightly, like this one, where you can tell that it's fairly new. It hasn't gone through a lot of passages, and in this case, probably no passages through any solar system. And therefore, it's vaporizing a lot of gas and ice that make it brighten up. Other ones get too close to the sun. There was one that just went by, I believe it was 2025 K1 or something like that, where they actually don't survive the journey around the sun, and they either break into many pieces or they just evaporate and they're gone. So we got lucky with this one in that it did brighten up a little bit where we had a chance to see it, but it didn't disintegrate, which is good. So on to the presentation. So, oh, this is his computer. Okay. This is just kind of an overview. I'm going to step out here right and see it a little bit. An overview of what is happening with it as far as where it is in the morning sky. And it says, looking east about 90 minutes before local sunrise. Of course, this is a snapshot of the sky. this is about what the sky looked like back in early November. For instance, Spica and Arcturus are much higher in the sky now at dawn, but so is the comet. And so as you can see, it's passing through kind of up the spine of Virgo, passing several fairly bright stars. And now it is going out of Virgo and up into Leo, unfortunately getting a little dimmer as it goes that way. But it's still within reach of a fairly, at least a medium-sized telescope. The kicker to it is before dawn, and it's pretty cold this time of year before dawn. Our weather is not always favorable for early morning stuff. Like this morning, I noticed we had a freezing fog. Stepped outside about 5 o'clock, and I was outside for about 5 seconds and went right back in. But anyway, it is there and it is available to see. And in a little more close look at it, over the next month, you'll see that it passes from this star over here. Well, the one down by the December 2nd cometary position is Beta Virginis, which is like the westernmost bright star of Virgo. And then it passes underneath the nebula and then into the heart of Leo, and then passes by Regulus just before the first of the year, right around Christmas night, that time of the month. And so it is in a fairly nice area to try to find things. There are a lot of galaxies around here, though, so you don't be fooled by a galaxy.
It's the dotted line, is that the ecliptic?
The dotted line is the ecliptic, yes, yeah. And so you'll notice it's right on the ecliptic, but it's going the wrong way. It's in an almost perfectly retrograde orbit, where it's going right along the ecliptic, but going west instead of east. Just happened to be that way. And there is no supernatural or applied alien technology to that. It happens all the time.
Thank you.
It's all one big scam, right? Cover up. Okay, this is my attempt at looking at it with my little 5-inch, back when it was a little brighter, right after Thanksgiving. Couple of caveats to this. I do live in downtown Tulsa. I just come back and was very jet lagged. This was at 4 o'clock to 5 o'clock in the morning, and it took me the whole hour really to find it and have any inkling that I actually saw it. So what that points out is that it's gotten a lot higher in the sky. It's a lot easier to see now. It's dimmer by about a magnitude, or almost a magnitude. This was back when it was right around 10th magnitude. It's now down to about 11th magnitude. Out at the observatory, for instance, or if you live outside of town, 6 or 8 inch telescope will probably show it just fine. It's not a large comet. It's fairly condensed, and so it shows up more like a little blob instead of some big cloudy, large, dim thing. So that will help. The 25 and the 9 millimeter, those are the eyepieces. So that would represent, let's see, it's 1900 millimeter focal length. So that's about 100 and about 200 power. So the power doesn't really help a whole lot. What would really help is getting out to a dark sky, and of course starting before the sky lights up for morning twilight. It rises now about 2 a.m. About 2 a.m. it'll be high enough to look for if you want to stay up late instead of get up early. This is the Cobbs is the comet. Not Comet BS, it's Comet Brightness System or something like that. Observed magnitudes from all over the world. People just, amateurs send these in, and that represents what they observed the magnitude to be. This was back on, I want to say the 6th today's the 6th or something, a couple of days ago. But not, obviously not quite December. Okay, so it was back to the end of November. And you can see that it's already starting to turn the corner a little bit, where it had reached 10th magnitude. It's down to about 11th then, and has gotten a little bit dimmer. And probably by the time we're talking about now, if you got up in the morning to look at it, it might even be 11 and a half. The curve fit is not necessarily the best thing. That's just a simple quadratic curve fit. So it may flatten out and stay bright. It may crater on us. You never know with comets. So you just have to watch. It probably will actually be moderated in its dimming though, because like I said, it's getting closer to us, even though it's receding from the sun. So that may help moderate the dimming a little bit. This is what I was talking about at the beginning. This is not to scale or anything, but this represents the type of orbits that we're looking at. The planets, the asteroids, most of the comets that are periodic will follow an ellipse, which is not a perfect circle, but a lot of them are close enough they look like it. A parabola is sort of the classic comet that is from our solar system and does come into the inner solar system and past the sun. It's probably actually an extremely elongated cigar-shaped ellipse, but it's so close to being a parabola, we just call it a parabola for convenience sake and say it's never going to be back. It may be back in a million years, but you know, we don't really care too much about that if it's that close to being a parabola. And then a hyperbola is one that is actually not coming back. It's what happens there is it has sufficient speed to reach escape velocity from the solar gravity. And so whatever pushed it into our gravity or sun's gravity field has also given it enough velocity to escape the solar gravity, unless it actually interacts with another large body like Jupiter, which this one's not going to. It didn't get anywhere close to Jupiter and won't on the way out. And then the orbital elements, just for grins, it gets a little, it doesn't pass quite as close to the sun as Mars, but it gets, as us, but it gets closer than Mars. Eccentricity, like I said, is 6, which is really high. Usually see them about 1.05 or 1.25 or something like that. The rest of them are kind of not that important, other than the inclination. There you see it's 175, which means it's kind of like being 5 degrees, like the moon is 5 degrees inclined to the ecliptic, but this one's going the opposite way. It's the retrograde. It passed perihelion on October 29th, and it doesn't say here, but it'll be closest to the Earth around December 17th. The absolute magnitude of 6.5 is really pretty bright for a comet. They usually run around 8 to 10. So it's intrinsically bright. Another clue that it's probably new. So, and that's it. The only thing I added to the other version that I remember, it might have been some cleanup. I did go ahead and publish 2 more books. Long story as to why there's 2 at the same time. I'll spare you, but if you're interested in either one of those, they are on Amazon. One of them is telling the story of looking and trying to sketch all the NGC objects, which I just finished, except I didn't finish sketching and am not going to try to finish sketching the NGC objects. I got all of them except the main part of the Large Magellanic Cloud. And I just decided this is just too OCD even for me. There was a guy there that's from Australia that's looked at the thing his whole life, and he said he spent a year observing and sketching the Large Magellanic Cloud. And I said, I can't move to Australia. I'm not going to do that. So that's it for that list. And the other one was sort of my backup in case, because I told everybody I'm going to put another book out. And then I thought to myself, wait a minute, what if I don't finish? So I put another book together, which is about, the first book was called How to Get, or what was it called? Take What the Night Gives You. all about calming down, purely anti-Brad behavior, enjoy the ride and all that good stuff. And this is called extreme astronomy, a little bit tongue in cheek. It's kind of like a reaction to that. It's not really so much trying to do too much in one night or anything like that. It's more about, we hear all the time, like this comet, for instance, you may hear or read somewhere, you cannot see this comet, period, dot. Okay. That's not true. Okay. You may have to get up early. You may have to, if you don't have a big enough telescope, you may have to borrow a friend's or go out with them, or you may have to rent some time on a imaging service or something like that. But the idea that you simply cannot do something, to me, is ridiculous. There's usually a way to do it. It may not be thinking inside the box and common astronomical lore or whatever, but a lot of times there are ways you could do things if you just kind of push yourself a little bit or think of a different way to do it. So that's what that's about. So, and as far as this, usually I give a talk on what's happening this month. There's not a whole lot happening this month. Jupiter will be at opposition early next month. There's no big conjunctions or anything like that. There are a couple of decent comets to look at. Other than that, not a whole lot going on. Does anybody have any questions about this or about the sky this month? Yeah.
Is the absolute magnitude for a comet at 1 AU distance?
What's that?
Absolute magnitude of the comet, is that 1 AU distance? How do they figure that?
That's absolute magnitude is generally for solar system objects. It's 100% lit, which doesn't really matter here. But I believe it's I want to say at 1 AU. So, there's a standard distance, and where the percent lit comes into effect is where you have a moon or a planet that can be lit. With comets, it really has a lot more to do with what's called their DC, which is degree of condensation. This one, like I said, is fairly condensed, so that doesn't really come into play. It's closer to being a point source than it is to being like a galaxy, but it could still fool you if you're looking for it. Like I said, it's kind of going into the field of galaxies right now. So beware of that.
Scott's not here tonight, but he caught it with his little sea star.
Yeah, I keep wanting to do that now, and I got one the other night, and
Picture.
I stayed up till 5 the other night, Thursday night, I guess it was. And just about the time I figured out how to use the thing and figured out how to maybe look at the comet with it, it clouded up. So, but there'll be other chances. It's not gone yet. And anyway, anything else? Okay, thanks.
Thank you, Brad. Another comment, John. Our next observing night's on the 13th Saturday, which is the peak weekend for the Gemini shower.
Okay, Dr. Lau, we are ready for you if you're ready.
Yeah, do we test the audio again at all?
Yeah, is this
Good.
better for everybody? Okay, I think we got it solved. So,
All right, and if I do, can I share my screen to your monitor back there?
yeah, you go ahead and share. Yeah, I should be able to.
Hold on 1 minute. Let me move some things around. Do, 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 do.
All right. I will turn off my video. I've already given you a little introduction at the beginning of the meeting, but I will let you take it away, Dr. Lau.
Cool. Sounds good. Firstly, I appreciate, I think it was Brad, I think I called his name,
Yeah.
mentioning that we have no evidence that Comet 3I Atlas is an alien artifact. I appreciate Avi Loeb for his speculations that he puts out about these objects potentially being aliens. I think we should have alien as a possible consideration when we look out into the cosmos and we see unique things. But I also feel like Avi's creating the scientist who cried wolf scenario, where he sees aliens in everything. And as I just published on my own Substack yesterday, there's a lot of fallacies in the way that Avi is approaching his arguments, not just about these things being alien spacecraft, but also the way that he's been attacking some other scientists um, and like dismissing them basically and saying they aren't credible because they're criticizing his idea. So I appreciate that because like it's a really cool time to be alive to see an interstellar comet. I mean, it's the third object that we've now sufficiently have shown has come from another part of the galaxy and entered into our solar system. It makes some of us wonder how many of these things have passed into our solar system over the eons that our planet has been here. Has any ever come to the planet? I don't know. Maybe long ago we had an impact from some interstellar object. And so I think it's really fun for this new era of astronomy in detecting these things and giving us a chance to learn more about them. And so what I've thrown together here is kind of a mix of some different things I talk about regularly. I'll mention towards the end here my idea of the Panzoic effect. If any questions come up, this is very general I'll be talking about, but if you have questions, feel free to interrupt me. Happy to answer questions during my talk or at the very end. I always have, when I talk to astronomy clubs, it's always interesting to see the range of knowledge. Some people are very well knowledgeable about astrobiology and about my science, about things like geochemistry and earth and space science. And then others maybe haven't explored as much yet. So I'm going to have a fairly broad overview of a lot of things in astrobiology. And then we'll kind of come back around to the space philosophy side of things. And I'll explain a bit more about that. But I do love speaking to astronomy clubs because generally you are the kind of people who nerd out over cool celestial things like I do. Maybe by seeing the Geminids, or going out with your telescope to look for this comet. Just trying to have these experiences. I mean, for me, I understand now after my first two total solar eclipses why some people will spend most of their lives chasing after the path of totality to see as many eclipses as they can. It's all rather staggering just to be connected not just to these amazing celestial moments that we're blessed by here on this planet, but it also connects us to our ancestors. Long ago, humans were experiencing things like solar eclipses and seeing the movements of the planets and wondering what was happening in the cosmos beyond our own world. And yet we live at a very remarkable time for the attainment of our knowledge and the way things are changing. Amongst your group, I'm sure some of you are quite aware that we're only about a century out right now from knowing that other galaxies even exist. This is the Great Andromeda Nebula from 1899, long before it was considered another galaxy, before we had these determinations that not only are there other galaxies out there, but they're also moving away from us at exceptionally quick speeds. This is obviously the famous Hubble Ultra Deep Field image from 2014. It's only the part of the image that fit on my screen. The image itself is rather big and shows some 10,000 galaxies, roughly 5 to 10 billion light years away. So much is happening so fast, and the way that we're learning about our place in the universe. Again, it's only a century since we've discovered that all these things are even out there to begin with, beyond the own cloudiness of our own Milky Way. For me, being a longtime space nerd, I love the imagery we have of our planet from the outside and the way that it's changed the view that many people have of our place in the universe. This is, of course, the famous Earthrise image from Apollo 8, the first time that we saw the Earth rising above the limb of the moon. Also famous images like the Blue Marble, taken in 1972, this one from Apollo 17, an image that was taken when they were traveling toward the moon, the last Apollo mission to do so. And this image itself is one that my company, Blue Marble Space, for which I'm involved not just in the nonprofit business, but also as a research scientist. We have the Earth flag, so the Earth Day flag, which shows a picture of the Earth. We've been using those to argue that when astronauts go to space, maybe they should just take one symbol for all of us on Earth together. And one good symbol could be this image of the Earth from 18,000 miles away. But again, for me, like I kind of walk this line between the science of trying to understand our place in the universe, and then also the philosophical and sociological side of our experiences, of looking at the heavens, of going out and doing amateur astronomy and just looking up. I'll admit for myself, I'm more of a naked eye stargazer. But my son is 6 years old, and I think he finally wants to get a telescope. So things could change there for the two of us soon. Um, but by looking up at the heavens, we really are connecting ourselves to an ancestry, to a heritage that we've had on this planet for a very long time. And like I said, with 3I Atlas, this is an interstellar comet, but it does make a lot of us wonder, Avi Loeb the most, about the potential for alien life out there. Maybe we will have a real finding of a technosignature, a sign of alien technology like a ship, or finding something that is a message or a signal in space, or looking at an exoplanet atmosphere and seeing signs of technology of alien life. And for me, being a longtime sci-fi nerd, one thing that really drove me towards my field is just wondering what aliens will be like if we ever do meet them. We have a lot of really cool ideas in our science fiction, but we don't really know yet if anything that we've dreamed of based on life as we know it, or creating humanoid style characters to tell human stories, if any of that will ever pan out to be remotely true in finding life in the universe beyond our own. But this is the study of astrobiology. It studies life's origins, how we came to be here, the evolution of life, how things have changed on our planet, and maybe importantly for most people is whether or not we're alone. Is there a distribution of life in the universe? Are there other things out there for us to explore? Based on our current knowledge, we do have to admit that we could be alone. There is some probability that we can't know exactly what the probability is, but there is some chance that it's just us. Until we find some definitive signs of alien life out there, we can't say otherwise. And I'll say to that though, even though I think we have to admit that to ourselves logically, there still is this strong human feeling when we look out into the universe and we see just how many other worlds there are. It feels like there must be something else. Like this can't be the only thing. And so it inspires a lot of us to want to keep looking, even if it inspires some people like Avi Loeb to maybe look and see a little too much. But astrobiology as a field, I'm going to cover just a few things that we do in astrobiology very briefly. I'll share some of my ideas of why I think life on Earth is fairly alien. I'll explore some of the stuff in our solar system that we're doing right now in the science, and then I'll come back around to this idea of our connection to our ancestral heritage, and why astrobiology for me is an experience of awe. Firstly, when it comes to understanding how life begins, there's so much happening right now in the realms of astrobiology. And in many ways, artificial intelligence is really speeding this whole process up. So for quite some time now, we've been looking for the primordial soup, a la Charles Darwin, trying to figure out like how did it begin here on Earth? Can life start in oceans or does it require land? We don't know the answer to that yet. Some people think that life might have started in our oceans around hydrothermal vents. I have two colleagues named Bruce Damer and Dave Deemer, who have suggested that that life can only start in wetting and drying cycles on land environments around hot springs. And if that's the case, then maybe ocean worlds out there don't have any life because they need dry land for life to start. We're also exploring like the range of chemical reactions that could go from chemistry into biology. How do we go through that process of abiogenesis? When does life begin? And are there multiple pathways? And like I said, AI is really changing this now. Previously it's taken, supercomputers processing these large chemical reaction networks, and you'd run it for days and days and barely get much of an answer. And now with AI speeding everything up, I think a lot more researchers in origins of life chemistry are becoming more optimistic of us finding potential pathways to life. Astrobiology is also interested in how worlds evolve. Some of us view biospheres themselves almost ecologically as individuals, and the biosphere itself is an individual that once life happens to the planet, it then alters the planet over time. The planet itself can go through geological change in the surface, through volcanism and plate tectonics. Of course, we have large-scale impacts from space. But that all also relates to how life changes the planet. And life certainly has changed our Earth. If we go back 3 billion years in time into the history of our world, Earth is a much different place back then. We humans are extremophiles to the Earth of 3 billion years ago. Um, and that planet certainly couldn't support us. We've evolved and adapted to this world and along with this world. And life itself has found so many remarkable and intriguing ways to move, to get food, to reproduce. Life is driven to fill every possible niche it can on our planet. And like I mentioned, for me, when I look at life on Earth, it feels like it's alien itself. There's just so much bizarre, awesome things happening within the form of life that we know the best. In science fiction, we often use what we know here on Earth to start drawing and creating what alien characters might look like. If any of you have played the Mass Effect video games, you might know there's an alien species that looks just like a floating Portuguese man of war. Of course, you've probably seen sci-fi films or video games or comic books or television shows that have things like isopods crawling around. I personally love the deep sea giant isopod the most of all of them. These are the guys that when a whale or a shark body falls in the ocean after dying and falls to the ocean floor, these creatures almost mysteriously come out of nowhere and start hawking upon this body and will eat down as much of it as they possibly can. They're rather remarkable. I sometimes will speak about what I call the craziest creatures on Earth, the way that some living things are so bizarre to us that they make us wonder what alien life might be like. One of my favorite of the most bizarre creatures are hummingbirds. We know of over 300 species of hummingbird on our planet. You hopefully know that they are the smallest birds. Some of them can weigh as much as like a paperclip or a small coin. Of the species we know, there probably are many that we just haven't found yet because there's a lot in like rainforests and other areas where they're very active. Of the species we know, we've learned a lot about them. They're about 25% of their dry mass is their chest muscles. So if you imagine birds in a weight room working out and lifting weights, the hummingbird would just be on the bench press the whole time doing nothing but benching. Because they need these exquisitely fine-tuned, humongous chest muscles for their body size to flap their wings the way they do. Their hearts can beat up to 1,200 times per minute. And to get that speed of their wings flapping like that and their hearts beating so fast, they have remarkable metabolisms. The different kinds of species that are out there have different requirements for calories. Most of them are somewhere in like the 3 to 6 calories per day kind of level. Some have a greater caloric requirement. But I averaged that out. I took the average known caloric requirement for hummingbirds, and it's not very high. If you think about a human, say we have like 1,500 to 2,500 calories per day as a requirement for our own nutrition. That's exceptionally high compared to what most hummingbirds are consuming in nectar each day. But if you divide that caloric intake by body weight, a much different story unfolds. And we see that the hummingbird has roughly a 77 times greater caloric intake per unit of body weight than what we do. And that's just astounding. I mean, there are certainly varieties of metabolism and dietary requirements across the planet, but the hummingbirds are some of the most bizarre. And if you want to know how bizarre that is, if you had this kind of caloric requirement, if your muscles in your chest were that humongous compared to the rest of your body, and you were beating your heart that hard and maybe flapping your arms super fast like that, you would have to eat about 155,000 calories a day just to stay alive. Let me give you an idea of how much that is. There's this place in Pennsylvania. I'm from Pennsylvania originally. There's this place outside of State College. It's called Denny's Beer Barrel Pub. They've been known for having some of the largest cheeseburgers in the planet. They have one that was over 100 pounds, was on the Food Network some years ago. This one is called the Belly Buster. It's a 20-pound, 25,000 calorie cheeseburger. If you had that dietary requirement like a hummingbird, you wouldn't have to eat just one of these every day to stay alive. You'd have to eat about 6 of these giant cheeseburgers. And even then, you still actually wouldn't quite be at your caloric requirement. You'd need a few milkshakes or maybe a Diet Coke. It's bizarre. It's bizarre to think about that hummingbirds are sharing this world with us, and yet they have a biology that is utterly alien and different from ours. Another creature that I really love a lot, I like thinking about the ways that we perceive our environment around us and how alien life might perceive its environment. If you know how hearing works, how our ears are able to pick up sound, it's very similar to touch, actually. So when we feel touch, we're feeling pressure in our bodies, we're feeling change in our bodies, and hearing kind of works similarly. It allows us to feel the pressure changes of waves in the air. So as the medium of the gas molecules around our bodies, sound can propagate as waves through that air. It can come from my voice into the speaker, into the microphone. It's leaving the speaker in the room and traveling across the room and going into your ears, where the smallest bones in your body are vibrating with those waves and allowing you to hear what I'm saying. We humans, we hear roughly around 2 or 5 waves per second. For some people with really great hearing, out to about 20,000 waves per second. Now, if you're a bit older like me, you probably can't hear 20,000 hertz, which is waves per second. For most of us, people past the ages of like 30 and 40, we start losing that higher range. We start going down to around 19,000 hertz, sometimes down to 18,000 hertz. If you're over 60 or 70, it usually is a lot lower than that, even under 17,000 hertz. In the UK, there are these anti-loitering devices they have, where they will play high-pitched sounds around 19 or 18,000 hertz, because teenagers will hear it in a parking lot and it'll hurt their heads and they'll have to run away, whereas anyone like over the age of like 30, for the most part, isn't going to hear it. So we can actually target human hearing based on age. But this creature, the greater wax moth, has the smallest hearing bones that we know of thus far. They're exceedingly small, and they also allow them to hear the greatest known range of hearing on our entire planet. So there are different ranges of waves per second that different creatures can hear. I just have them here, relative hearing ranges set up, showing that things like bullfrogs and many birds actually don't have very good hearing. Their range is usually pretty small. We humans have a fairly decent range. Of course, your dog can hear out to 50,000 hertz, which is why dog whistles work. But then we have creatures like dolphins and bats. And I'm sure some of you in the room might know how dolphins and bats, how they perceive their environment around them. They use echolocation. And one of the reasons, at least we think, for the greater wax moth to have such a humongous range of hearing is that the only natural predator we know of for the greater wax moth are bats. And so they've evolved back and forth in an evolutionary arms war with bats to be able to hear a little bit better than they can. But that's not the only cool thing about their hearing range. What really intrigues me with their hearing range, when you put the actual numbers on it, is where they're hearing. So again, we humans hear like a very low frequency, bassy kind of sound out to maybe 20,000 hertz if we're very young. But the greater wax moth, as far as we know, its hearing range is something like 50,000 hertz out to about 300,000 hertz. So not only is it hearing high frequency sounds that we will never ever be able to hear with our own ears, but their range of hearing is utterly alien compared to ours. It's kind of bizarre if you think about it. Like they literally are hearing something you will never hear, and everything you hear, they can never perceive. And that just feels weird to be on this planet sharing it with creatures who have such an alien perception compared to ours. And I'll finish with one more creature I think about a lot when I think about alien life, and it's trees. Tree is a biological process where some plants, many of which are not immediately connected to each other evolutionarily, some plants from across the entire tree of life of plants, some plants have figured out how to get a little bit taller to reach for starlight, to get some sunlight into their light collecting organs in their leaves to live. They're a sign of convergent evolution. Sometimes evolution causes divergence, where species and populations will start splitting apart from each other and new species can form that way. but sometimes life converges on certain things like flight. Flight evolved independently in birds and in bats and many insects. And tree is similar. Tree is a convergent process. And so it makes me wonder, are the processes for convergence we see in life on Earth also happening out there in the cosmos? And if so, there might be many worlds that have trees, a variety of different kinds of trees, but trees all the same. And that's kind of cool to think about. So I'm going to jump here into this question, are we alone? What are we doing right now in astrobiology? Not only in considering all the weird stuff happening on our own planet, but looking out into our solar system and beyond and looking for signs of life. And I'll start here in our solar system with some of the favorite planets amongst astrobiologists, or favorite worlds amongst astrobiologists, in looking for possible signs of life, like Enceladus and Mars, Venus, Titan, Europa. Venus is one of my personal favorites, even though, as many of you probably know, that modern day Venus has an extremely hellacious surface with 92 times the surface pressure that we have. I think it's around 900 degrees Fahrenheit. It's about 450 Celsius on the surface. And yet there are some of us who wonder, could there be any biology happening in the clouds of Venus? You might have heard some years ago that Jane Greaves, an astrophysicist and colleagues, suggested based on some radio telescope data from two different observatories that they'd found signs of a gas called phosphine in the atmosphere of Venus. On Earth, phosphine is only produced naturally through biological processes, through the breakdown of living matter. Famously, it's most concentrated in our planet in penguin guano. So penguin poop has the most phosphine on Earth. But we do find phosphine in natural environments without life. We know that phosphine forms on Jupiter, it forms on Saturn, and so we don't know for sure if on Venus it necessarily is an indicator of life. And it's one reason why several government agencies want to send new missions to Venus. And there's also a private company called Rocket Lab, which now has the third most launches on the planet this past year. They're based out of New Zealand. They're also aiming at sending a mission to Venus, potentially to look for signs of life there. But the one world that gets the most love most of the time is Mars. I'm a big fan of Mars as well. I've been out to the Mars Desert Research Station in Utah and have done analog astronautics. I've dreamed of putting foot on Mars myself and what our future might be like if we ever have human habitation there, or at least human exploration there. Mars is currently the only world that we know of that is solely inhabited by robots. At least that will be the case unless we find signs of alien life there. And even though I think Venus was far more likely early in the solar system to have life, I think Mars is the obvious candidate right now for us looking for signs of life being preserved over time in the rock record. And when we go to places like Mars to look using our rovers and our orbiters, our landers, we need analogs from here on Earth to help us. And so there are astrobiologists who travel to deserts around the planet, to places like the Atacama Desert, a very high, very dry, most of the time desert in South America. There are places with creatures thriving in high temperature and acidic environments, like in Yellowstone National Park. This is my favorite place in Yellowstone. If you haven't been, you should definitely go. This one is called Grand Prismatic Spring. All the coloration of oranges and yellows and reds and greens towards the outer edges of this high temperature hot spring are caused by pigments inside of the cellular structures of living things. Just a quick aside, if you do go to Yellowstone, stop in the gift shop and get a copy of the book Death in Yellowstone. It shares a bunch of the ways that stupid people mostly have gotten themselves killed in the park, including things like approaching the bison and being mauled, which happens far more often than it should. But one of the most terrifying ways in this book is people who step off of these boardwalks and collapse into the hot springs. Again, super acidic, super high temperature. Most people that their bodies die of shock first before they start to basically melt away. Yeah, it's awful. So yeah, pay attention to the signs. There's a reason the scientists and ecologists have put those up there. But back to the science. Places like the Atacama and deserts and high places, dry places, hot spring environments help us to understand what we're looking for. Is they help us to see the signs of what an ancient Martian environment might have been like if it had life. and what kinds of signs it might have left behind. Similarly, this is a place I've been to in the high Arctic, about 500 miles south of the North Pole, on an island called Ellesmere. In this picture from 11 years ago, I'm standing on top of a geological structure called a gossan. Gossans are features that form in environments where there's iron sulfide ore that's been emplaced very close to the surface, and then it begins getting leached by rainwater. And as the water kind of percolates into the soil, it reacts with the metals. They release acid and they release the iron and the sulfur into different minerals, and they form these rusty, reddish colored zones, these big circular structures. And myself and others have argued that these probably exist on Mars. And if they do, they could be oases for ancient life to have thrived on Mars. They'd be very difficult to spot in the Martian environment because they wouldn't stand out, because all of the Martian surface is rusted this way. But we could potentially find them with our rovers. We could just drive over one, and there are some telltale signs that we could see that would show us those in the environment. But the main reason that I traveled to this place in the high Arctic was for a much different analog, not to Mars, but for icy worlds. So this is a view of this valley called Borup Fjord Pass on Ellesmere Island. You're looking down from the eastern side. You can see some orange dots down kind of in the bottom central part of the image. Those orange dots are our tents where our field camp was set up for a few weeks. And then you see this glacier on the far right, and right in the middle right of the image, there's some yellow material coming out of the glacier and then starting to flow down a valley here along with some meltwater. The yellowness of that ice is why we traveled there in the first place. It's the only place on the entire planet where fluid from beneath the glacier is erupting through the glacier and carrying with it hydrogen sulfide from the subsurface. That's the smell of rotten eggs. If you've ever smelled hydrogen sulfide, when that hydrogen sulfide reaches the surface, it goes through processes chemically, both because of the atmosphere, but also because of the living things that are present, the microbes that are present in these fluids, and they create these large mats of elemental sulfur. This sulfur, this yellow coloration all over the ice and the snow out here, it gives us a way, one, to study life in a sulfur-rich environment that's metabolizing primarily on sulfur, but it also gives us a way to look for possible signs of life we might find in other worlds like Europa. Europa, one of the 4 Galilean moons of Jupiter, has these large crisscrossing lines called Linnea. Inside of them, we found sulfurous materials, just like at my field site in the high Arctic. And we wonder, could they be indicative of communication geologically from the surface to the subsurface? And what would that mean? Could there be signs of a Europan biology stored in the surface? We have a mission heading there right now called Europa Clipper. It will arrive around 2030 and begin observing Europa through flybys while it orbits around Jupiter. And through those flybys, we'll be studying the chemistry of the sulfur and other materials at the surface. It'll be studying the environment around Europa. It'll help us to better understand as well the depth of the ocean down below. Based on our current best models, we think that Europa's thick icy crust is maybe something like 6 miles in thickness. And then down below that is an ocean that might be something like 60 to 75 miles deep. That ocean is way deeper than anything we have on Earth. But if there is a potential that, much like on Earth, we do have biological oases on the seafloor, then maybe they could happen on Europa as well. There might be signs of life within Europa. Again, it requires that life can start in oceans, which we don't know for sure yet is possible. But if it can, maybe there are systems on the seafloor or in the ocean of Europa where life has originated and evolved, maybe forming things like giant tube worms, the Riftia pachyptala we find here on Earth, or even albino creatures, maybe animal-like creatures down there on the seafloor, or maybe it's all just cellular material around hot spring environments, these hydrothermal vent environments on the seafloor. A couple of other worlds we're looking at very briefly in our solar system. One is Enceladus, a very small moon of Saturn that has these large plumes of water coming out, forming the E-ring of Saturn. But we know that Enceladus has a much smaller ocean, but still an ocean down below its crust. And we know that there is this process allowing for water to plume its way out of the Enceladus surface. And so some people want to send now robots over to Enceladus and maybe go explore those plumes, maybe even try to crawl down inside of the cracks and see if they can get to the ocean if it's accessible. Another one we're looking at too for astrobiology is Titan. This is a mixture of UV and IR imagery of Titan. The main reason here is just showing that the thickness of Titan's atmosphere. Titan's a really intriguing world because it has this methanological cycle occurring in its atmosphere and surface where methane and ethane are evaporating. They're breaking down through photochemistry in the upper atmosphere and forming a large number of various hydrocarbons and nitrogen-rich materials that's then raining down as like an organic goop onto the surface. I personally think it's highly unlikely we would find signs of life on Titan's surface. It is exceedingly cold, so cold that it should preclude any kind of chemical reactions to allow for metabolism or life. But it still makes us wonder, could there be zones within Titan's surface, maybe even in the ocean, where that organic chemistry is allowing for some processes of life to occur? We really don't know. But again, these are like places in our own solar system that we're looking at actively with upcoming spacecraft like the Dragonfly, which I'm not quite sure yet with the new schedules when it's going to launch. It was previously launching in 2027 with arrival in 2036. I think that's getting pushed back a good bit now. But this will be a humongous drone with eight propellers that will fly around on Titan and teach us a lot more about the chemistry and geology, and who knows, maybe the biology as well. Now, of course, we're looking out a lot more beyond our own solar system. We have James Webb Space Telescope right now, making new discoveries all the time, looking into the chemistry of exoplanet atmospheres. We have upcoming telescopes like the Nancy Grace Roman Space Telescope. And then there's one being developed and designed right now at NASA called the Habitable Worlds Observatory, HabWorlds or HWO. With Nancy Grace Roman and HWO, we might really be getting some of the greatest sensitivity we could have right now to look for possible signs of life on these alien worlds. And so much is changing so fast. Again, it's been a century since we've discovered other galaxies even exist. And now we have so much data coming in. I'm sure for many of you here, you're much like me, where when I was a kid, we had no evidence of exoplanets even existing at that point. And now we have over 6,000 that we know of for sure, with many more that will be confirmed fairly soon. Who knows what the near future holds with our discoveries and detections with exoplanets. We could be right on the cusp of potentially making that first major detection. And that makes me think a lot about my favorite quote from all of science fiction, which is from the novel Dune by Frank Herbert. There's a Fremen saying to be prepared to appreciate what you meet. And I think when it comes to alien life, we need to have that kind of stoic mindset as well. Because there's reasons to both be hopeful and potentially fearful if we should find signs of alien life out there. I'm going to jump just for a minute. So just to talk a little bit about what we're looking for in our own galaxy. Some of you might know this. It's the famous Drake equation, written by Frank Drake in 1960. It was brought together because he was organizing a working group of scientists and researchers to meet up at Green Bank Observatory and to discuss the question, what do we need to know to figure out if there are alien civilizations out there with whom we can communicate via radio right now? And famously, he structured that as this giant N, this capital N, is the number of communicating civilizations in the galaxy right now. To get there, they started thinking through what we do know and what we need to know. And so they started off with the rate of star formation, which is actually something we can know. Some number of stars form every year, if we're using year as the unit time within the galaxy. I think the best right now is like 2 to 3-ish stars per year. But you can also multiply that out and make it even bigger and start with the full number that we know of stars in the galaxy. There's a lot of ways to view this number. But then you start breaking down the possible places where life could exist at any given period of time by fractions. By proportions, it starts off with F sub p, which is the fraction of stars that have planets. Now that we're finding planets around every single star for the most part that we're looking at, it seems that fraction is pretty close to 1. The number of worlds that are Earth-like or at least have some setting where life can originate, we have no idea what fraction of planets are remotely hospitable for life or where life can start yet. But it seems, likely that there will be other Earths out there. We're already finding Earth-sized worlds. It's probably only a matter of time till we start finding others that have similar environments to the early Earth as well. After that is where we start to lose a lot, though. From the number of worlds where life could start, how many have life? We have no idea what the answer to that is. It could be an exceedingly small fraction, but even then, it's still maintaining some number of possible other civilizations. From there, we look into things like intelligence, this F sub I. How many biospheres develop the intelligence to start communicating at all? And with that, how many develop the F sub C, the ability to use radio waves to communicate? Back then, we were looking primarily at having SETI messaging coming through radio, but now we look in a bunch of different areas, different kinds of ranges of EM radiation, different ways of light being used to send signals, different kinds of signals we might detect in the universe, maybe even like gravitational wave signals. So there's a bunch of other possible realms of communication. And real quickly, this whole where is life? What has intelligence is a big question, and we honestly have no idea. We humans like to think of ourselves as being exceptionally intelligent. We've built grand things over millennia, like the Great Pyramid. We've done things like build skyscrapers and smartphones, and now we're developing AI. But we also see other possible signs of intelligence on our own planet. Certainly, so these are termite mounds in Australia. The termites are a eusocial creature, much like bees, where they have what appears to be a colonial intelligence, a hive mind intelligence, where a single individual doesn't appear intelligent, but together the hive does rather intelligent things. We see communication, of course, across our planet from many different species, like whales. Even right now, we're trying to use AI to see if we can figure out what whales might be saying to each other, if there's any way for us to understand that. I personally like thinking about things like the corvids, like crows and ravens. They're exceptionally intelligent birds. They show great signs of intelligence. And so on our own planet, we don't have an answer to this question, but we look out in the cosmos, there's a lot of possibility. But I really brought this equation up primarily because of the final part of it. The very last factor is a lifetime of civilizations. How long does a civilization last? And you need that factor to cancel out the unit time that you start with. And then you get some number of civilizations. And we really have no idea how to answer this question. It tells us more as a thought experiment about what we don't know right now about life in the universe. And so if ever you read in the news that someone has an exact answer to the Drake equation, they are wrong. Until we find some signs of alien life and really begin engaging in a larger cosmic conversation with them, there's just no way for us to answer this question. A few years ago, a couple of researchers put out a paper saying the exact number was 37. And again, it was just based on a bunch of assumptions they made without really having anything to support those assumptions. But the L factor, I think, is crucial to this because of the timing of when Drake brought those researchers together to think about this question. In 1960, we were becoming ever more aware of our own potential to end our civilization. Sometimes I hear people talk about like nuclear war and climate change and things like that, and they're like, well, we're going to destroy the Earth. It's highly unlikely that we're going to destroy the Earth or even drive all of life to extinction. What we're looking at is the end of our civilization, the end of human life. And that's something very terrifying. And we still have tens of thousands of these nuclear warheads all across the planet, positioned and ready to end our civilization at any moment. I think, though, when looking at the Drake equation, it was important for 1960 to add in the lifetime of civilizations. But now we're in a new moment where we have to question the lifetime of a biological civilization. We have AI, and it's only a matter of time. We're going to start seeing humanoid robotics in use across our planet very soon. We're already looking into these realms of life extension, of human augmentation, developing greater medicines. The entire fate of what it means to be human might be changing rather soon. We might be nearing the end of our biological human civilization and moving instead into something that's post-biological, something that comes after what we've been. And for those of us who study in realms like philosophy and psychology and sociology, this is a massive question of what is this future that we're creating right now, and are we ready for what we're creating? And so I'm going to skip some of my slides here, I think, to jump instead to talk about one of my favorite topics, which is the philosophy side of looking at ourselves from space. I'm rereading right now one of my favorite sci-fi books from all of history. If you haven't read it, I think you should. It's called Star Maker by Olaf Stapledon. He published it in 1937. There's a part in the book where a human consciousness is leaving the Earth and looking back at our planet from the outside. And he thinks to himself, or he writes that the sheer beauty of our planet surprised me. It was a huge pearl set in spangled ebony. I seemed to feel as never before the vital presence of Earth, as of a creature alive but tranced and obscurely yearning to wake. And I find that beautiful. I think we are in this moment, maybe not as a creature yearning to wake, but as a civilization and a biosphere. We are waking to something new. We still are hindered by our ancestral tendencies towards warfare and to amass wealth and power. And yet I think many of us feel this connection. We look at the stars and we feel this connection with the cosmos, and we feel something bigger is possible. One reason I love getting people to read this book, though, is not just the depth of the story he tells and the way it goes into considering alien life and the nature of our universe. It's also for the prologue. Again, he wrote this in 1937. And at that time, when he first started working on this book and was about to publish, he had colleagues, both in the science fiction and philosophy realms, who were basically saying to him, like, how can you write a book like this right now? How can you write a story where a human consciousness sees the Earth from space and goes and meets aliens and stuff like that, when we know right now, like, it was very clear in 1937 that Europe was on the brink of war. And, people were aware already that Jews were trying to escape from Germany and Poland and other places. It was clear what was coming, that we were about to face one of the greatest human crises in our history. And in the prologue to the book, Stapledon answered that question. And one of the most profound things he said was that perhaps the attempt to see our turbulent world against a background of stars may, after all, increase, not lessen the significance of the present human crisis. It may also strengthen our charity toward one another. I think that's the value of a lot of what we're doing in astronomy and looking at the stars. We're seeing ourselves in something bigger, this part of our world. And I think it's why looking at the Earth from the outside is so powerful. My friend Frank White in 1987, he wrote a book called The Overview Effect, which he actually coined the term in 1985 originally. In the late 70s and early 80s, Frank had realized that no one was asking the astronauts what it felt like to see the Earth from space. He originally reached out to NASA, and he was like, "Can I talk to astronauts about what they're going through?" And NASA was like, "No, you can't talk to the astronauts, but you're allowed to reach out to any retired astronaut you want to." And so Frank started contacting every single person who had gone to space and was no longer working for the US or for the Soviets as an astronaut or a cosmonaut. And he started the process of interviewing them. And before long, he had so many interviews that NASA was like, oh, well, now that you're interviewing all the astronauts, you should interview the active ones too. And so Frank has interviewed almost every single person who's gone to space, including the more modern times with the space tourists now as well, going up and seeing our Earth from the outside. And he noted in his 1987 book, which is now in its fourth edition, that a lot of the astronauts had seen the Earth from the outside and reported having a range of experiences, but there were a lot of similarities. And he calls that the overview effect, that a lot of these people were feeling a psychological shift in how they viewed themselves as being human, how they viewed all of us together and the precarious nature of our world, our own threats to our place in it, and also the need to do something to make our world better. And for me, talking to Frank about this, it feels like the overview effect really is one of the deepest experiences of awe that's available to us. There's a beautiful book on the nature of wonder and awe by Dacher Keltner, where I love his definition of what awe is. It's being in the presence of something vast and mysterious that transcends your current understanding of the world. I think there's a good chance many of you, when you've, looked through telescopes with your own eyes at the heavens, you've probably felt the experience of awe. It's what drives a lot of us into astronomy and to fields like astrobiology. And for me, I've traveled this world, I've spoken to so many people, I've heard a range of experiences, sometimes fearful, sometimes hopeful about alien life being out there. I feel like most people generally think there are aliens out there. For most people I speak to, and I started the process now of surveying people to try to get a better sense of what people are really feeling. But it seems to me that people are having an experience of awe and wonder when they think about alien life and they think about our place in the universe. And so last year I coined this term the Panzoic effect to explain what's happening. Speaking with Frank about the overview effect, I felt like what I'm seeing happen right now with people thinking about alien life and our place in the universe, it's a way of looking out beyond our planet and experiencing a similar thing to the overview effect, that we feel a shift in our own experience. And as Dacher Keltner pointed out in his book, there's a lot of great research right now on the experience of awe and what it can do for us. A lot of people who've gone through experiences of awe through the research have also shown a tendency towards pro-social behavior. People who are experiencing wonder and awe are more likely to be empathetic, to be sharing and caring, to want to support other people, to think beyond themselves, to feel selflessness. And just like meditation, climbing a mountain, watching a child being born, dancing with your friends, all the experiences we have as humans that let us feel this deeper sense of ourselves and this greater sense of the vastness of the cosmos and our place in it. I think thinking about alien life can be that as well. And so I think I'll stop there, and just open it for any kind of conversation about aliens you might want to have.
Thank you, Dr. Lau. That was awesome. Does anybody have any questions for him? Any comments? Yes, sir. Gibson.
Can you hear me?
Are you able to hear?
A little bit, yeah.
Hello, hello. Okay. I wanted to ask about your interpretation of the data that was taken from the exoplanet K218b, and the discovery of dimethyl sulfide and dimethyl disulfide on there. What's your take on that?
Yeah, so for everyone, so the exoplanet K218b, it's just a designation because it was found during the second iteration of the Kepler mission. It's just the number we use for it. There's a researcher, last name Madhusan, in the UK. He and a couple of his colleagues, a few years ago now, suggested the detection of dimethyl sulfide on this exoplanet. That'd be exceedingly intriguing because much like phosphine, on Earth, dimethyl sulfide is formed by life. And then it came back into the news more recently because the same research team used a bit more data from the James Webb Space Telescope to suggest that they were supporting their findings of dimethyl sulfide, DMS, as well as another molecule, dimethyl disulfide, DMDS, again, also formed by life here on Earth. And actually, if you go down to like the ocean and you smell something that kind of, it's almost, sometimes it smells like rotten fish. A lot of people associate with like rotten fish, but that ocean smell that you usually get, that's kind of like almost like organic material in your nose, is oftentimes from dimethyl sulfide and dimethyl disulfide. It's formed a lot by phytoplankton at the surface of the waters of our oceans. And it's actually a part of our atmosphere. There is some dimethyl sulfide, dimethyl disulfide in our atmosphere. It's very small in our atmosphere, but it is there. I will say, so like the finding of it could be intriguing if it is really there. It could be really intriguing because much like phosphine, it could be a sign of life. However, it would not be a diagnostic sign of life. It wouldn't be an immediate, oh, that's it. That's not a smoking gun, because dimethyl sulfide and dimethyl disulfide have also been found in space and other places without life. Dimethyl sulfide in particular is one molecule we found in interstellar clouds. So it's out there. And there are chemical pathways to make both of them without having living things present. That said, just like phosphine, though, it could be really intriguing of a finding, and I think we should look for it even more. However, one of the main issues that Madhusan and his colleagues have is that other people have looked at their exact same data, and what they've done is they basically have some data and they've applied a mathematical curve, a plot to it that requires having some curves up and down to explain the data. And those up and down curves are what creates the peak that suggests the dimethyl sulfide, dimethyl disulfide are there. Other researchers, some of whom I really respect and know very well, and I trust their mathematics. One in particular was a student of mine named Ryan McDonald. They've analyzed the exact same data and have found that an even better mathematical fit to those data is a flat line.
Hmm.
If you put a flat line through the data, it basically means there's nothing there. And so far, Mado-san and his colleagues have not done any sufficient job to explain why the flat line fits better than their curve. And if anything, I'm actually kind of bummed with how Mado-san himself has treated this. Rather than try to work with others and talk about it, he's gotten really defensive, which is unfortunate. It is a human thing, though. Like we scientists are also human. I think for many of us, we would be super into it if those molecules were there, but we just need better data to support that interpretation right now.
All right. Thank you, Dr. Lau. Anybody else? Any other questions or comments?
Do you have an intuition about whether AI may figure out how to make the connection between chemistry and life?
Yeah, AI could figure it out before we do. I mean, we might not only be creating the first alien intelligence with whom we might have a conversation could be AI. It could be something that comes from us, and that'd be pretty wild. But AI is also doing incredible work right now in solving some of the problems we have that are humongous data sets that require a lot of processing. There's a lot happening right now in the realm of using AI for the future. Even for the Habitable Worlds Observatory, I was speaking on my show, Ask an Astrobiologist, which I host for NASA. I was speaking with one of the researchers who's involved in developing the entirety of the mission, not just the telescope, but also all the science and the scientists, all of the administration side of things. And she was saying that they're really thinking of how to build AI into the entire cycle of mission development and planning, of instrumentation building. And then also they're thinking of deploying autonomous robots on this telescope that might be able to fix the telescope themselves if anything breaks, which I find pretty radical, and I'm really hoping we see that happen. AI is changing so much in our lives right now. And I know a lot of people, they hear AI and they think of things like ChatGPT and Claude and Gemini and these large language models. And there's a lot of philosophical, ethical issues with the use of these models and how they're being trained. That they're forcing us to ask a lot of things about intellectual property and copyright and how that's going to work in the future. How we respect art and artists and creators. When we have AI out there trawling the internet and using everything it can find to create for us. But there's also AI well beyond LLMs. Artificial intelligence and machine learning is really being used a lot in science and research right now, and it's only going to increase.
I could actually speak to that a little bit. So I don't know if you know Dr. Lau, but I'm working with Dr. Jim Cleaves
Mhm.
at Howard, and we've been working on our Enceladus paper for about a year now, and we use AI, whether it's ChatGPT or have you ever used OpenBabel?
Mm-mm.
Okay, well it's a chemistry application that you can plug in what compounds you have, and it'll run a kind of like an evolutionary reaction, and you can go through different generations and iterations, but it uses AI kind of like a large language model and extrapolates what it could be. And so yeah, I'd have to agree with you on that, Dr. Lau. It's pretty much hand in hand at this point. So
It's changing a lot.
yeah, it's crazy.
And again, there are people too trying to use AI to figure out how to talk to whales.
Yeah.
I don't know if this is going to be possible. I do have concerns, but I'm curious to see if it works.
Mm-hmm. Anybody else? Any other comments, questions? Okay. Well, if not, we'll go ahead and wrap it up. Thank you again to Dr. Lau. Was there a question, John?
So when you finish.
Okay. Well, thank you, Dr. Lau, for your time. We really appreciate it.
Yeah,
And
it's been a pleasure chatting. Do not try to eat a 20-pound cheeseburger, by the way. You're not gonna make it.
Don't tempt me, you know.
I did a 7-pound burrito once, and that was pretty rough.
Oh, mercy. No, that's crazy. But yeah, if you all would put your hands together for Dr. Lau.
Cool. Well, thank you all. It's been a pleasure.
Well, thank you again, and hope to talk to you soon.
Cool. Bye.
Have a good one.